Hello guys and gals, me Mutahar, and how's it all going, ladies and gentlemen? It's your weird uncle teaching you about computers today. Yes, I've got an interesting computer video, a little nerdy video if you will, and this was actually inspired by a few postings that I've been seeing around the internet regarding video games. Now, in the last couple days, a game like Chrono has sort of come out. Now, I actually owned the game physically on the PlayStation 1, absolute banger game. They recently released a re-release, a remaster of this game. Don't buy it, it's garbage. I'm going to be real with you. Just play the original if you can. Emulate it, run it on an original PlayStation or a PS3. Just don't get the remake, okay? It's dog water. Now, because of this remake, I've been noticing a few things, right? A lot of people who are actually playing the original version of the game on the PlayStation Vita, the original download, actually noticed that they started losing access to their download. So for instance, on this one post, you can download Chrono for the PlayStation 3. Then later on it would say the content has expired and is no longer available. Of course, one thing to notice is the expiration date. January 1st, 1970. Now, why is it that this date is rather important? Because this didn't happen out of maliciousness, okay? I want to start off by saying, while it's very timely that this happened around the re-release of this game, this actually is par for the course for a lot of games that are on the current storefront. And what this has to do is time. Time is something that we human beings calculate in different ways, right? There's different types of calendars, right? We've got the Gregorian calendar, which is the current calendar that we predominantly use here in North America and basically around the world. Currently, the year is 2022. And the way that we do it is we use something known as an epoch, which is basically a point in time that we use as a reference to when that calendar began, right? So the epoch for the Gregorian calendar is basically Jesus Christ's birth and death. You know how we do BC and AD, before Christ, after death? There's other calendars, like the Hebrew calendar, which calculates according to Genesis's time of the world, like when the world first began. Currently, they're in the year 5782. The Muslim calendar, which calculates a time when the Muslim prophet and his followers migrated from Mecca to Medina, that is running in the year 1443 after Hijri. So basically, we all have different epochs, and there are more calendars than this. You've got the Buddhist calendar, the Chinese calendar. There's hundreds of calendars, okay? You got the Indian calendar, you've got the Ptolemaic calendar, which is from ancient Egypt. You got a bunch of different calendars. But this is not important. What's important is how a computer sees the calendar. Now, this is where computers have a scope of the end of time. Now, of course, the world is ending for computers, for 32-bit computers. No, this title is not clickbait. Yes, the world in their eyes is definitely ending, trust me. To understand what it is we have to talk about the Unix Epoch. For those of you who don't know what Unix is, effectively when I use Linux, when you use Mac OS, when you use iPhones, modern day devices, you actually have a Unix-based system. A lot of the servers that are running the internet that we are using are on Unix servers. Granted, a majority of them have been updated, but Unix is a massive operating system that exists. And it first started back in 1969 when it was known as Unix, okay? So UNIC is what we used to call it. Now, of course, this later became Unix, and this is when, in January of 1970, is when the engineers back then, the programmers of yesteryears, decided that was the time epoch for Unix at that point. So effectively, how a computer calculates its time all the way up to 2022 is it just counts the seconds. So because we started from 1970, all these computers are doing to keep track of time is just counting the seconds since the day that the epoch is known. So if you actually look at the epoch right now for Unix, we're at 1.6 billion seconds. This number is going up as the seconds go on. A lot of the Unix-based systems and servers that we have are using this Unix epoch time. Now, what makes this interesting and what really brings upon the end of the world for systems is as it's counting those seconds up, a lot of these values, most of them are stored in a lot of these 32 signed bit integers. Now, the entire problem here is these integers can only see values between -2 to the 31st power and 2 to the 31st power, okay? This is otherwise known, I believe, as the 8th Mersenne prime. So effectively the number is 2.147483647, all right? This is the magic number. Once these 32-bit systems reach these seconds, they'll basically flip back to the number 0, okay? They basically cannot see beyond that scope because these data values only allow them to see number values between that end and the negative. So here's actually a visual representation of what you're supposed to see. So for instance, right here in this section, the number is counting up from 313, right? So again, this happens at witching hour, January of 2038. But in 8 seconds right here, this decimal value will flip the script. So look very carefully at 1 second later, it's now calculating backwards. Because this is in a signed 32-bit integer on a Unix system that hasn't been changed and updated, it's basically going to start counting back. It's basically not going to be able to see beyond those seconds. Now, this basically causes an issue on a lot of embedded systems and legacy systems, systems that you may not be able to update or even reach. And so what can happen is it starts incorrectly calculating incorrectly starts calculating databases, a lot of files, a lot of issues can start to form. Think about it like this. The computer, up until this point, before that decimal started going backwards, notice the time is 2038. Because of that decimal change, all of a sudden, it went from 2038 to thinking the time was 1901. That can severely fuck up systems. You might remember back in the year 2000, we had the year 2000 bug, which was basically what people believed that once a system reached 1999, what would happen if it reached 2000? All right, would it calculate? Would it just believe that it's the year 2000? Or would it roll back to the year 1901 and fail to recognize time? Well, there was a lot of engineers behind it that basically future-proofed and updated systems and fixed as much as they can so we didn't have to deal with those issues. But to understand, this situation is alive and dandy, and it doesn't have a uniform solution. Now, again, going back to that PlayStation issue when we actually saw these licensing problems, because it's not the year 2038, the way that they're calculating time checks for verifying digital licenses may have been an issue on the back end, and it's up to Sony's engineers to make sure that they fix these digital licenses so people do not have lost access to these various games that they've purchased for tons of money, okay? Which is why people say, I'm crazy, Muda, why do you buy physical discs? You know what doesn't have a date epoch issue? This, when I put it into a system. This, when it's booting up. You know what has an issue? A licensed server that relies on a server that hasn't been properly maintained. Of course, Sony can fix this going forward. No issues on that one. Hopefully they should. I hope they do, and I believe they will. I hope. Now, in a lot of cases, this really does affect embedded systems, legacy systems, and a lot of binary blobs of software that probably isn't maintained accurately very well. A lot of software that people use, especially developed in modern times, uses higher level data structures to actually represent things like date. Again, counting the seconds is actually pretty archaic unless you're just doing like global system uptime or something like that. Database software, for instance, as far as I know, on Linux again, that uses time T, actually does store in pretty safe formats, okay? Well beyond 2038. But if you're running, say, a 32-bit Linux server or something in 2038 and you haven't updated shit, then you're going to be running into some issues and you're going to expect some downtime, all right, for things to turn around. Now, you might be like, oh, we're fine till 2038. Again, the PlayStation issue I showed you just kicked in because of what seems to be an issue on the back end. Something that Sony can relatively fix over the course of a day or two of just patching around all these license issues. But even things like AOL, for instance. I know, some of you are like, what's AOL, Muda? And fuck you for making me feel old on that one. But AOL designed on their server software, effectively, they were handling database requests. And they had designed a system that would never actually time out, from what I believed. Now, to handle this specific situation, they basically set a arbitrary timeout date sometime in the future, right? I think at some point their default configuration for the server was to basically time out after like 1 billion seconds have passed. So 1 billion seconds, all right, after the year 2006, May 12th is what I think the date was set in my notes over here. Effectively, after that, the timeout calculation had overflowed and returned dates that were actually way into the past. And this, of course, caused that system to actually crash. So until the AOL engineer sat back, redid the configuration file, this would be the issue. So think of it like this, okay? What you're seeing is an integer overflow. Now, an integer overflow, I want you to picture it like this. This is the easiest explanation I can give. Imagine you're driving an older vehicle, right? Where the odometer is a manual odometer. You know when they had 6 digits and they actually rolled up physically on a dial? So typically, they would be in 6 digits, right? Now, this would be able to calculate any mileage from 0 all the way up to 999,999 miles. Now, nobody's going to drive an old clunker for nearly 1 million miles, but the option is present. Now, what happens in those older manual systems is when you reach 9999999, after one more mile, it's going to read as 000000. It's not the fact that the engine is brand spanking new, it's that the system we designed is not able to read 1 million miles. Think of it the same in this situation. Obviously, as vehicles got more advanced with digital dashes, now they can display 1 million miles. But this is something that you have to expect. This is a good way to visualize what's happened, right? And of course, as you can imagine, this causes a lot of issues for all those back-end systems. Now, even if you're talking about space shuttles, which have embedded systems, what was rather interesting was a shuttle known as the Deep Impact, right? Now, the Deep Impact space probe was sent out, I believe, back in the year 2005. But because of something on its fault control system, I know, ironic, the fault control system on it fucked up. What actually was kind of happening is one of the chief scientists basically said it was a Y2K-esque problem, where basically the software on it, some of it didn't actually roll the calendar date correctly. So effectively what was happening over here, some of the embedded systems on it basically was calculated in an integer value that recognized somewhere between like, I believe it was 4 billion seconds or something, like 2 to the 32 power. And effectively at this point, because that system, the fault protection system, was misreading the time, the system was just constantly rebooting. And effectively, like, the space agencies decided just not to communicate to the probe. It was a lost cause. No one was going to go out there to update the embedded system. And of course, that's the key word. Those embedded systems, if they're affected by the year 2038 bug, may be nearly impossible to fix. In fact, even when it came to iPhones, when they updated to 64-bit processors, apparently when you set the time before the year January 1st, 1970, that epoch point, it would actually permanently brick that device. So it would be stuck in a complete boot loop. Of course, until you took it to Apple and they updated it and they reset the phone properly on their systems with their software, you effectively had a fucking bricked phone. And that's something to expect from these epoch issues. That's something to expect from the 2038 issue. It's actually that simple. Now, you might be like, but Muda, you said a lot about issues. What about fixes? Well, there isn't actually a straight up simple fix to the 2038 issue, or a universal fix, right? So think about it like this, all right? Even if you look into the C language, right, the way that they calculate is the time T data type, all right? And if you started to change that around, even from signed 32-bit integers to unsigned, it would cause code compatibility issues. Even if you made an unsigned 32-bit integer, it only delays the issue till 2106. So, of course, what we did was when we started to release 64-bit systems, so 64-bit processors, operating systems, because of the 64-bit value for time t and a lot of these integer values, it went from the year 2038 problem to calculating time in seconds all the way up to, from now, to 292 billion years later. And this is so far in the future that it actually bypasses the actual age of the universe. So we don't really have anything to worry about in that department. If humanity lives beyond the age of the universe and reaches 292 billion years from now, well, we'll let the engineers then figure it out. But till now, we don't really have that big of an issue. So yeah, hopefully that makes you understand how the situation works. And hey, there is another big issue that's coming up, and that's the year 10,000 bug. The way that we read years is rather interesting, right? Like we have 2022, but that's 4 digits. What if we reach the year 10,000, basically the next ice age? We need 5 digits, and there are in fact companies that are dealing with calculating in 5 digits, but that just leads into the year 100K problem, okay? Then the year 10,000, like we get into issues, okay? We need to solve integer overflow. And it really is, hey, we're reaching this time, let's add 1 extra 0 and make sure everything is updated. But look, you and I and our great-great-great-great-great-grandchildren will be dead by that point. But what do you think will happen if operating systems just from a few years ago, decades ago, run the year 10,000? Hell, you can even load up Windows XP and be absolutely surprised at what'll happen to the system. It downright freaks it out, and you can actually try it for yourself in a virtual machine. So here I got an example of Windows XP, and if you look at it, I'm running Windows XP Service Pack 3, and of course I got 1 core and like, I think recognized maybe 3 gigs of RAM, if that. Now it's a 32-bit system, so what I'm going to do is I'm actually change the date here from the year 2100 all the way to 10,000. And by doing that, it's as simple as typing in date. You type in 01-01-10,000. And of course, the system does not accept that date. So what we do here is we type in, go into run, and we do cboot ini, and over here in the boot ini, we're actually going to add 1 argument right here. So we're going to go do /year equals 9999. So if I can actually spell it, so right here, now we're going to reboot the system after we save this, and then we'll change the date to 10,000 just by moving up the time naturally. So here it is, the system is now 1 minute away. So what I'm going to do real quick is get out of here. I'm not taking a tour, okay? It's already been 10,000 years. You can see that as the time is updating, and we'll open up the time right here, it's going to give me 1 more minute before it actually hits the big year 10,000. So here, look carefully over on the system. I've got the processes, CPU usage is very little, and of course I can actually start opening up other things in the actual system. When I reach the year 10,000, the system is actually going to start freaking out. So it does a bit of CPU calculation when I'm opening up things, but just wait for 30 seconds. Let's just move time forward. So as we start to reach the year, well, 5, 4, 3, 2, 1, and bam! So now we're suddenly in the year 10,000. The system is trying to calculate what's going on. It hasn't actually been able to change the year. What's happening right now is the system is actually locking up. So it's reaching 100% CPU usage. It's completely spiked, and the system has all but locked up. Now, of course, it did change the year to 10,000, but unfortunately, the system is completely fried. It's locked up. There's not much we can do. I can't even change the year if I wanted to. Okay, so again, we're back in a usable system. Of course, the year 10,000 will absolutely crash the system because of that integer overflow and the fact that the year 10,000 is not going to function well with Windows XP. So if you are using Windows XP in the year 10,000, be very cautious. But you know what, ladies and gentlemen, I wanted to really make this video because I like teaching people about computers, and I thought this was a rather interesting concept. You know, when you look at computers, they seem like really abstract, machines. But in reality, it's quite simple how they handle certain things. You may have been wondering how a computer reads time, and it does it in an entirely different way than we human beings do, which is look at a calendar, look up our phones, and do practical things. Computers literally are counting the seconds. And when you go over a certain data value threshold, the computer freaks out. Hey, load up Grand Theft Auto 5, make over $2.1 billion, and watch the money count freak out. That's how data values work, and that's how they're stored. So hopefully you learned something. Hopefully you're not freaking out at the fact that Sony's taken away your games, because if you think this is a problem in the year 2038, you're probably going to see it with a lot of legacy servers going on forward, and this issue is going to creep up from time to time over the internet and over various servers you go to, because the various backends that we use rely on constant maintenance and updates. And if you rely on older software and older services, well, you best hope that those systems are updated constantly and maintained by a passionate group of people. Because if they're not, well, you could lose certain things to time, and certain software could face some serious compatibility issues. That said, though, this is me, Mudahar, and if you like what you saw, please like, comment, and subscribe. Dislike it if you dislike it. I am out.